Assalamualaikum warahmatullahi wabarakatuh everyone. My name is Muhammad Zabidi, ID AA24109, and today I'm going to cover for cross-section part in Headcraft. First of all, you've got to download the Headcraft software first. You can reach there in Kalam, so you can download it from there. And then after you download it, it will appear like this, and you can open it. After you open it, you have to create a file, a new project. This is where the place where you can save or put the file, the location of the file that you are going to put. So you can choose which one that you want, and then you choose document for this, and then create the folder. There you can name your file. So I will name my file as aircraft cross-section assignment. Okay, and it will appear like this. Alright, after that we have to give the name or the title of the file, and I will name it as aircraft cross-section assignment task, assignment hydraulic, and then okay. Before I forgot, make sure that there is no space between these words, and make it like this. After that, you can click OK. You have to make it no space so that you can save the file, or else you can't save the file. So make sure there is no space. After that, you click OK. Okay. Okay. After that, as you can see, there is a notice saying that it is in US standard. So you have to change it into international standard. You can change it through this way, options and program, this unit system, and you can change it here, change it into SI unit, and click OK. Yes, as you can see, the SI units appear right here. So that means that we have changed it from US customary to this SI units. Okay, so next we are going to input the geometric data. So to do that, we have to click at this part, view or edit geometric data. You click here. Okay, after that we are going to draw the river, but we have to know how many rivers that we have. So based on this file, we knew that we have 3 rivers, which is we have river Lipis upstream, river Lipis downstream, and we have Tempora river. So we are going to sketch for Lipis river and Lipis upstream. To sketch that, we have to click here, and then we make a line here, and then you just double click here, and you name it. It's a Lipis river, and the reach is Lipis upstream. Okay, name it according to the Excel file, Lipis upstream, and click OK. So you have it for the Lipis river, reach for Lipis upstream. And for addition, I want to add some info to say that this arrow is showing the direction of the river flow. Okay, after we get the Lipis river for Lipis upstream, when we look at the spreadsheet, we have tempera river. So to draw tempera river, just use like the same way when we sketch the Lipis river. So click here and sketch here until it touches here, the Lipis river. And then we name it. It's a tempera river. And it's the name of it is tempera. So we name it, the ridge is tempera. And we click OK. So the program said, do you wish want to split Lipis river on ridge Lipis upstream? You can click yes. Okay, after we click yes, there is a space here where we have to name the river. So let's see what's the name of it in the spreadsheet. So it says that it's still the same. The name is Lipis river and the ridge is Lipis downstream. So we remain river as Lipis river and we do here as Lipis downstream, and we click OK. So after that, the system asking us to require the name of the junction. So to gain the name of the junction, you can see from spreadsheet also where it says junction name is LT. So we write LT junction. And we click OK. And we click yes. And here, there you are, there is a LT junction. So as we can see, we are sketching this freely. The river, the tempera river and the Lipis river. So to assign the coordinate, we have to use the tools. So to assign the coordinates, you can click GIS tools and reach invert lines table. And here where we can insert our coordinates for schematic X and schematic Y. Okay, after we open, what we can see here is at here river we have Lipis river and tempera river, and for the ridge for Lipis river we have Lipis downstream and Lipis upstream. So how do we want to insert the coordinates? So first, let's say we choose Lipis upstream first, and we can open the Excel and okay, I'm so sorry, I actually opened the wrong file of the Excel, but although it happens like that, Alhamdulillah, it still not affect a lot, and it's still the same like here. I'm sorry, it's still like the same. It still has a Lipis river upstream and downstream, this one, and also we have tempera river. Okay, I'm so sorry for that, and let's proceed with the inserting for the coordinates. First, we want to insert for the Lipis river upstream, so we can copy here, copy, and we can insert it. You can drag as much as you want, and you can control V. I'm sorry, you can copy like this, and here you are, you have the coordinates, and if you unsure, you can confirm like this. You can see, is it the same? And you can see the coordinates is the same as what we have copied. Okay, and after that we can insert the coordinates for the river, Lipis river, for Lipis downstream. you can open here and open the Excel and see for Lipis downstream and copy the file. Copy like this, and you can insert it right here. Control V, and here you are. You gain the data for Lipis River downstream. And after that, you can do the same way for Tempera River. You click Tempera River, and for the reach you can click Tempera, because we only have Tempera for the reach. And we can open the file and do the same way, copy like this, and just copy like the same as we did before, and control, and here you are. You have the geometrical data for Lipis River, Lipis upstream reach, and Lipis downstream reach, and also for Tempera River for Tempera reach. Okay, after you insert all the geometrical data, you can click OK. As you can see, this is the Lipis River sketch for the downstream. I'm so sorry, there is a mistake after I click the OK, and Alhamdulillah I managed to get the structure of the stream river, the real geographical shape of the surface of the river. So you click OK after you insert Tempera River, Lipis River for Lipis downstream reach and Lipis upstream reach. You click OK, and here we are. We got the real surface of our Lipis River, and for downstream and upstream, and also for Tempera River. Okay, after we open the cross section part, we have to name our station. So to name our station, you can reach that by open the spreadsheet, and we can see right here we have the river station 10.212, 10.195, 10.177, and etc. So let's start with the Lipis River and Lipis upstream first, shall we? So the same way we are going to do. First, we have to name the station first. We can click options, add a new cross section, and we name the station that we want to do. So it says it was 10.212, isn't it? Okay, back to the part. So we are going to name our station 10.212, isn't it? For Lipis upstream, Lipis 10.212, and we click OK. After that, we are going to copy all of this and insert it into this column for the station and for elevations. So copy, and we put it here. Control, and here we are. We got this. And okay, now we want to insert the value of downstream reach lengths, mannings and values, main channel, bank stations. Okay, to get these infos, first we have to know what river, and we know it's a Lipis River, and which reach, we know it's a Lipis upstream, and which station. This is very important. It is at 10.212 station. Okay, now we can see here at 10.212, we can see like this part is our information that we have to insert. And also for main channel bank station, we can see it right here. It provides information here. And also for cont stroke XP coefficient for steady, you can see contraction stroke expansion. We can see the value is provided here. Okay, now we have to insert it accordingly. So first, let's go for the downstream reach length. So my ID is AA24109 and my X would be 1 and my Y would be 0 and my Z would be 9. So let's insert it. Okay, after I insert all those values, I apply the data and we can see there is a 2 red dot here. These 2 red dot means at our normal water flow, it won't exceed at these 2 red dots. And after that, we have done the cross section for station 10.212 for Lipis River and for Lipis upstream. So we are going to do the same for the other stations and for other river and for other reach. So please let me insert it first and we will catch back. Okay, after I have inserted all the uh, data, all the values, as you can see, let's go for Lipis River first. For Lipis River, for Lipis upstream, I have inserted all the stations and this is the elevations and I have inserted the left bank, the right bank, the Manning's value and the downstream reach length. And I have inserted according to this Excel file, and as we can see every stations for tempera also we can see the cross section of it, and I also do that for tempera river for all stations including for Lipis river for downstream reach. We can see here a lot of station has been inserted the value of the station and elevations, and it's also uh, can be seen the 2 red dots which is the boundary of the river flow. Okay, after we do that we have to save the file, so let's save the file. So we to save the file we can click the file and save geometry data. Okay, so because we do at HECRA procession assignment, so we have to save it here. The file should be saved in here, and let's name the file, and I would name it as a cross section. Maybe I would name it as geometry cross sections, and then save.
Okay, this is the junction from cross section that I have made previously, and then you can put a junction length with 0 or a certain of number. It is depending on the data that you have in the HECRAS Excel. So here I don't see anything data that available in HECRAS Excel, so we can to put it to the 0 or 1. And also we can have a lot of junction. We can see here the junction 1. So here we can to make an edit for this junction 1. Never mind, you have see the geometry data, so you can to save the geometry data. So now you can close it and copy your geometry data to data. So you can copy it and paste to two data, and we need to make a rename to two of that data. One is for steady flow and the other one is for unsteady flow. So I think it's now for the junction part. I will pass it to my friend.
After that, we are going to continue for unsteady flow and steady flow. But first of all, you have to copy the file first from the previous file that you did for cross section. So first, I have done for this one, Hecra's cross section assignment, and I copied it into two. This one is for steady flow, and this one is for unsteady flow. And now we have to open in the file, and let's do for steady flow first, shall we? So open this file, open project, and choose steady flow that we have saved before. This one and this one. Okay, and here we are. We have Hecra assignment steady flow. And this is what we want it to be appeared. Okay, so how do we start to do the steady flow? I'm sorry. So first of all, we have to go to this button right here. You can start clicking. Okay, so here's the information where you have to fill in, and it says that you can insert for 30,000 max of the flow. So there is so many. Okay, so let's insert it. So we have to insert uh, the PF1 for Lipis River and Lipis Upstream Reach and etc. So how do we insert it? So we have to open our Excel, and here we are. So go to the steady flow data, and here is it. You just have to refer from here. So as we can see, for Lipis River at Lipis Upstream Reach, the PF is 2250. So just write it down, or you can copy it like this, just to make it faster. So just copy like this and like this. Okay, now we are done for this. Now we have to insert for reach boundary condition. So for this part, okay, so let's go to insert it. Okay, so this is the reach boundary conditions. So it says that for, sorry, okay, I think I've got to maximize it. No, no, okay, like this. Yeah, sorry. Oh, okay. So for okay. So for Lipis River, Lipis Upstream, for the normal depth is 0.001. So we have to insert the the value. Okay, so let's insert it. So the value is normal depth. So click normal depth and insert the value. So for this is 0.001, and you click OK. And for this one, it's a normal depth, isn't it? For Tempura River and the Tempura Reach. So normal depth is 0.000, sorry, 0.00. Click OK. This is also for normal depth. So it's a 0.001 and click OK. After we insert all of this, we can click OK, and we can apply the data, and here we are. And you can also recheck the value that you insert before, like for this one, for each boundary conditions, you can recheck it back whether are you inserting the right value or not. If you are confirmed that you are inserting correctly, you can click OK. And as usual, every time that you did, you have to save the file. So let's save the file for this. So go here and save flow data, and you have to name it. So let's name it together. So I want to name it as a flow data. Flow data. Uh, yeah, like this. Or maybe I will do the assignment. Assignment. After that, and remember, no space between here. Always, there is something between it. Don't let it space, like empty space here. After that, you can click OK. And then you can see right here our steady flow. There's a flow data assignment. Like previously, there is no written here as steady flow, isn't it? So right now, after we do for flow data assignment and we have saved it, so this is the flow data assignment, the file that we have saved before that we've just done. Okay, now I would like to show you how to run an analysis for our steady flow. So if you can see here, there is a sketch person here, a very handsome guy here. You can click here, choose mixed, okay, and you can compute it. So this shows an analysis, and it shows that our steady flow simulation has finished. And yeah, this is the running analysis for our steady flow. Okay, so maybe some of you would ask, like, how do we want to see the result, right? Like, we have run the analysis and we want to see what it shows. Like, is it showing something? It is showing something. So it shows, it brings us to a water profile. So let's see where we can see water profile. Maybe it's here, I think. View profile. Click this button. Yes, okay, so this is it. So this is a water profile for Lipis River, for Lipis upstream bridge. It shows everything. This one is for Lipis River, for Lipis downstream, and it shows Tempera River for Tempera Ridge. So it shows a lot. This is our water profile. Okay, now I want to show you how do you want to see the cross-section view. Okay, so you can click here for steady flow. You can see, click here and cross-section. Ta-da! Here is it. So it shows our cross-section for Lipis River at Lipis upstream. So as you can see, this is our cross-section, and yeah, we can see for each station. So this is our station. Yep. So, and we can also look for temporary. Okay, and for Lipis River, for Lipis downstream. So this is a bit a glimpse of cross section for each river, Lipis River and Tempera River. And if you want to get into more detail, you can also see the detail from output table here. So you can see the elevation, you can see the top wing, all these things. All those information you can gain from here, the detail. Okay, that's all for steady flow, and let's moving on with our unsteady flow. Okay, now we are going to do for unsteady flow. So the same way we are opening the steady flow, that is what we are going to do for the unsteady flow. So open the file that you have copied for unsteady flow. So this is my file. Okay, and open the Hecras file, open project, find Hecra unsteady flow assignment. That's my name, file that I saved, and this one. Click OK. So here we are. It shows unsteady flow. Okay, so where should we start in order to do for unsteady flow? Okay, the first thing is go to this fourth button. I think here it says view or edit unsteady flow data. So click this. Okay, and yes, the same way we are doing for steady flow, whereby we have to refer our Excel data and unsteady flow data here. Okay, so this one is for 10.212 station. This is it. This is the data that we have to insert for flow hydrograph. So here is flow hydrograph. So click here. Okay, so first what we have to see is that, okay, so what we have to see here is that first we have to see what's the time interval here. So the time interval here is 0, 6, 12, 18. So it's every 6 minutes. So choose 6 minutes here. Six minutes. This one. So 6 minutes, and we choose fixed start time, and we set the date today, which is 19 of June 2036. Okay, click OK, and then we set, let's say it's 12 the midnight. Let's set that, and click this one. We got this. Okay, so we can copy this up. We just copy the value of Q. This is the value of the Q that we have to copy from here. So just copy it directly, as simple as that. Just copy it. Okay, copy as much as you want. Control C. Okay, and then Control V. Alright, so this is our data that we have copied directly from the Excel, and then we click OK. Okay, we have done for Lipis River at Lipis Upstream Reach. Now we're going to do for Tempura River. So for Lipis River downstream, let's just KIV for a moment. We are just going for Tempura River at Tempura Reach first, shall we? So let's go. The same way we are doing for Lipis River. The same way. Sorry, so it's for Tempura River, isn't it? Yep, that's it. Okay, so it's the same way. The interval of it, we have got to see it first. So it's every 6 minutes. Okay, it's every 6 minutes. Okay, and time, yeah, it's right here. So which is 6 minutes. 6 minutes, and the date, let's choose it today as always. Okay, okay. Fixed start time, and let's start at, yeah, oh sorry, my bad. Okay, so that is it. Just copy the same way that we did for Lipis River and Lipis Upstream Ridge. Here we are. Okay, and we just click OK for that. Now we got moderate condition flow hydrograph for Tempura River and Lipis River. Okay, for Lipis River, Lipis downstream, as you see here, uh, at the axle, it shows the normal depth, not flow hydrograph. So we choose normal depth instead. So normal depth here, and we insert the value of it. So it's a 0.002, and we click OK. Okay, after that we have to go to the initial conditions, and in this part we have to give them a number. You can give them anyone you like. So let's choose 1, 2, and 1 instead. After that you can apply the data. Okay, after that, don't forget, always remember to save your unsteady flow data. So save the unsteady flow data. Let's go, and I want to name it as unsteady flow data sign, and we click OK. And as you can see, we have our unsteady flow data assignment that we have saved before. So please remember that you have to save the file that you did: steady flow data, unsteady flow data, a cross section of the geometry. So that's very important, so that you uh, you can save your works, and it save a lot of time consuming, so that if you uh, remember that you have to save your file, you don't have to redo it again. Okay, uh, same like before, like steady flow, we have to run the analysis, and same to be here. For unsteady flow, we also have the way to do the analysis. So how to do analysis for unsteady flow? So you just gotta find another picture, like the second picture of this handsome guy. Just click here. Okay, from here you just click all of this, just click. Okay, click geometry preprocessor, unsteady flow simulation, and post processor. After that, for the starting date, choose today's date. So today is 19th of June 2036, and ending date the same day as starting. Starting time, I choose at 12 at midnight. Ending time, I choose at 5. So it takes around 5 hours something. Okay, so for computation interval, it's up to you how much you want to choose, 5 minutes or something. Same goes to the hydrograph output interval and detail output interval. So I choose 30 minutes for this part, hydrograph output interval, and 30 minutes for detail output interval. Okay, after that, we compute it. So this is our analysis that have run by this software, and alhamdulillah, it's good, there is no error, and it's a finished unsteady flow simulation. Okay, now let's see on our unsteady flow data profile. So to see that, you can click on this one, click. Yep, this is it, the same like steady flow data. You can see like here, this is the profile for Lipis River, Lipis Upstream Ridge, and this is for Tempera River for Tempera Ridge, and this is Lipis River for Lipis downstream ridge. Yep, very beautiful. And as you can see here, this is the water level of uh, Lipis River, Lipis downstream, and you can see it's a very small line here showing that our river here has just exceed uh, the boundary of the Lipis river. Okay, the same thing that we can do steady flow, we can see the cross section the same way we can do for unsteady flow. We can also see the cross section. So just open the cross sections, and yes, this is the cross section for unsteady flow for Lipis River upstreams, and this is for Lipis River downstream, and this is also for Tempera River. This is our cross sections, and this is our boundaries. And we can see it for every station here. Every station. Yep. This is for station 10.158, 10.141, 10.106, and etc. Same goes to for the pistons. Same way for each river station. This is for 0.079, 0.062. And also, like previous, we can see the output table. So you can see the detailed output table from here. Yep, this is for temporary river detailed output table for unsteady flow. You can also choose Lipis river, or you can choose the ridge. So this shows detailed output for Lipis upstream for the velocity head, the elevation, the top width, uh, 59.08, the area of a 424.40, and also for Lipis downstream. Okay, so that's how we do for unsteady flow. And for steady flow, we don't have to set a time like the way we did just a minute ago, where unsteady flow have to insert the date, insert the time, where the fixed time that we want, what's the interval time that we want, uh, and all those things. But for steady flow, you don't have to do that. So that's the difference. Like for steady flow, you don't have to insert the time, the interval time, but for unsteady flow, you have to insert the the interval time, uh, the date, okay, the fixed time, all those things. Okay, and make sure that before for make sure that for steady flow and unsteady flow, make sure you run the analysis first, so that you know that it's either got an error or it can be analyzed correctly. So you have to ensure that first. So always remember that you also has to run an analysis, not just simply just do it and just simply save it like that. You just have to remember that steady flow and unsteady flow gotta have to run the analysis too. All right, I think that's all from me, from my group. I hope that uh, this video can help uh, explain thoroughly related to the hack rush. And assalamualaikum warahmatullahi wabarakatuh.